Good afternoon all. So in the last session we have seen what are the limitations of the single layer perceptron, and then we went for multi-layer perceptron, credit assignment program, and error correction learning method. So today we will see another type of learning rule of neural networks. So there is Hebbian's learning rule. So Hebb is a researcher, so that's why that name Hebbian's learning rule. So the definition in neural network context of this Hebbian learning rule is like as follows. If two neurons on either side of the synapse, I think you know the synapse, connection link between the one neuron to other neuron. So if two neurons on either side of a synapse are activated simultaneously, then the strength of that synapse is selectively increased. Just in networks also, two nodes and connection link. Likewise here, two nodes, one synapse or connection link. So on both sides of the synapse, there is presynaptic as well as postsynaptic. We'll call it as presynaptic as well as postsynaptic link. So if both the nodes are activated simultaneous means at a time if both are activated, then the strength of that corresponding synapse is selectively increased. It will increase the strength. If two neurons on either side of the synapse are activated asynchronously, one instead of one at a time, if it is not activated one at a time, that is asynchronously, then that synapse is selectively weakened or eliminated. So both should activate simultaneously at a time. Simultaneously means at a time, then the synapse strength will increase. If both activated asynchronously, then the corresponding synapses will strength will decrease or weaken or eliminated. So such a synapse is called a Hebbian synapse. So which performs the actions similar to this explanation. Those synapses are called the Hebbian synapse. What are the characteristics of that Hebbian synapse? The characteristics of the Hebbian synapses are as follows. It is time dependent and it is highly local and it has strong interactive mechanism. So time dependent means both should activated simultaneously, means if first synapse is activated, that is before synaptic link, the other end of this node or the other end of the synapses link should also activate at the same time dependent, to strengthen that weights of that connection links both should activate at a time. That's why it is time dependent. It is highly local, so it will take the information from the local neurons to whether need to activate or, so it is completely local. Locally it will gather the information and it has strong interactive mechanism. So because of that strong interactive mechanism only, both will try to activate at the same time or synchronously. To improve the synaptic efficiency as a function of the correlation between the presynaptic and postsynaptic activities. So to improve that synaptic efficiency, we need to, so it will become the function of that correlation between the presynaptic and postsynaptic activities, means that correlation should be there between that presynaptic as well as the postsynaptic to follow that or to have that above characteristics. Correlation is developed between the presynaptic as well as postsynaptic nodes. So it is time dependent mechanism like I explained. It refers to the fact that the modifications in a Hebbian synapse depends on the exact time of the occurrence. So both the nodes, if you take the single perceptron or if you take one connection link, that is synapse, on either side of the synapse you have nodes. Those two nodes should activate exact at a time. That means it refers to the fact that the modifications in Hebbian synapse depends on the exact time of occurrence of the presynaptic and postsynaptic signals. So that's why it is purely depends on the time. That's why it is time dependent mechanism, and it has local mechanism. The locally available information is used by Hebbian synapse to produce a local synaptic modifications. So it will collect the information. The synapse will connect the locally available information, and whether it need to be act like a Hebbian synapse or not, that will decide. That in collected information will decide whether it need to be activate like a Hebbian synapse or not. Because increasing or decreasing the weights of the connection links means we are indirectly changing the output. To get the desired output, which neurons need to be fired, which neurons do not fire. So that entirely depends, or how the output will fluctuates. That will depends completely on the weight adjustment. That's why it's like a training algorithm, right? Based on the collect, collected data, whether few synaptic links will act like a Hebbian synapse or not. That will decide whether both the nodes, presynaptic as well as postsynaptic signals, need to occur simultaneously or asynchronously. That will decide based on the local available information. So it has a strong interactive mechanism. A Hebbian form of learning depends on a true interaction between the presynaptic and postsynaptic signals. So it completely depends on the true interaction. That is, it has strong interaction as well as the correct or strong true interaction between the presynaptic and postsynaptic signals. The interaction is deterministic and statistical in nature. Exact information will be shared between the presynaptic as well as the postsynaptic. Next one is conjunctional mechanism. The condition of synaptic efficiency is the conjunction of the presynaptic and the postsynaptic signals. Hence, it is called the conjunctional synapse. So it will have some connection. So based on that strong connections only, it works in this conjunctional mechanism. Correlation mechanism. The condition for synaptic efficiency is the correlation between the presynaptic and postsynaptic signals. Hence, it is called the actually correlational or conjunctional synapse. So here actually the same meaning like it should have strong relation as strong connections. Both should be there, then only it is possible to have this Hebbian synaptic characteristics. Hebbian characteristics are Hebbian synaptic characteristics. So next one is the synaptic enhancement or depression. Synaptic weights, that is nothing. Enhancement means enhancement of weights or depression of weights. So whether it need to be strengthened or whether it need to be weakened. So how it will happen? The Hebbian synapse, so it increases its strength with positively correlated presynaptic and postsynaptic signals, which has some positive correlation or positive signals. Signals means positive trends the corresponding post signal as well as post synaptic signals as well as presynaptic signals decides whether it increases the weight or decreases the weight. So this will see with the example at the end. So it increases its strength with positively correlated presynaptic and postsynaptic signals. If it is negative means the weight will be decreased. If it is positive means positive trends means it will increase. So what is anti-Hebbian synapse? It weakens the positively correlated presynaptic and postsynaptic signals and strengthen the negatively correlated presynaptic and postsynaptic signals. It is quite opposite to that Hebbian synapse. If it is positively correlated means in the Hebbian synapse it will strengthen. But here if it is positive in the anti-Hebbian synapse, if it is positively correlated means then it weakens. Along with Hebbian synapse, anti-Hebbian synapse, other classification is non-Hebbian synapse also. So both Hebbian and anti-Hebbian synapses are time-dependent, highly local, and strong interactive in nature. Those are the Hebbian characteristics, right? Both Hebbian as well as anti-Hebbian synapses are having those characteristics. Next one is non-Hebbian synapse. So it is non-Hebbian synapse means it is not at all Hebbian synapse. It doesn't involve a Hebbian mechanism of either kind, either enhancement or depression. It doesn't involve any kind of Hebbian mechanisms. That is nothing but non-Hebbian synapse. So a simple example for this Hebbian synapse, anti-Hebbian synapse or non-Hebbian synapse. Generally, if we attend any workshop, in that if you want to correlate this synapses with the participants, then Hebbian synapse means it should have a strong connections, correlation, time dependent means if two persons are there, if one person says some hi or if one person asks something in the WhatsApp group or directly physical with physical presence. Let us take a WhatsApp group as it is online. In the online, if we say something hi or if we post our doubt, few persons will respond quickly. So those are belongs to the Hebbian synapses. So time dependent, both are occurring simultaneously. If we are sharing some information, people will be reacting immediately. So that strengthens the relation between the two persons. Whenever next time the other persons ask some doubts or other persons say some hi, first person will say also in a react in a similar way. So that's what like that the bond will increase. Here enhancement means in a similar way. If interaction is more, if it is quick interaction, if it is quick response, then the bond will increase in a similar way. Likewise here, both should activate simultaneously. Like there is an example. Anti-Hebbian synapse means those who are not reacting. If we pause now, they may react a little later. Both are not occurring simultaneously. When the others also doing the same thing, we will also react in a similar way. So those belongs to the anti-Hebbian synapse. The non-Hebbian synapse means few people will not active in the group itself. So those belongs to the non-Hebbian synapse. That means those doesn't involve any a relation, either saying hi or replying to the doubts or replying for some information. So those are not at all, they are in the group, but those are not at all active in that group. Those belongs to the non-Hebbian synopsis. Three kinds of synopsis, three kinds of people like that. Simple correlation. So it is Hebbian means those who are active. Non-Hebbian, sorry, anti-Hebbian means, even anti-Hebbian doesn't mean that it should depress, right? Or it should decrease. So that doesn't mean that people will lately react, and also they will give some opposition, or they'll give some they'll oppose the first person views. If we say something, it may not be correct, so it may be like this, so why you are posting like this? People will be ready to oppose the one person views. When others also, such kind of people are posting something, this first person also will react in a similar way. There is nothing but anti-Hebbian synopsis. Therefore it will do, the relation will become more worsen. The relation here, the weights will decrease or weaken. So first person's hi means hi, both are positively involved in that mechanism. That's what Hebbian synopsis. If it is anti-Hebbian means it will make the relation worse. Non-Hebbian means they are not at all involved in the discussions. With the mathematical modeling, consider a synoptic weight WKJ. WKJ is nothing but the connection link between the jth vector to the K neuron of neuron K with presynaptic and postsynaptic signals denoted by Xj and Yk respectively. So Xj is the input, Yk is the respective output of the neuron. The connection link between the Xj and Yk weight is nothing but WKJ. The adjustment applied to the WKJ weight between the Xj and Yk at time n is expressed as number of iterations are n. So for that particular n time, the corresponding change in weight del WKJ is equal to function of some Yk of n comma Xj of n. That is nothing but it is a where f is a function of the both postsynaptic. Postsynaptic means Yk of n. Presynaptic means Xj of n signals. Postsynaptic and presynaptic signals. See these Xj of n, Yk of n. Already we have seen simple block diagram. The simple block diagram, if you draw the line, Xj of n is at input, Yk of n is at the output node. If we draw arrow, above that arrow will mention with some weight. That weight is nothing but WKJ. Now you just visualize Xj line Yk, then in between WKJ weight. So before that line, after that line, that's what it indicates, perisynaptic as well as postsynaptic. So your function f is nothing but post and presynaptic signals. That's why f of Yk of n comma Xj of n. So what is the Hebb's hypothesis? The Hebb's hypothesis is as follows. The change in weight is expressed as del Wkj is equal to neta Wk of n into Xj of n. Here neta represents the learning rate and Wk of n is nothing but postsynaptic signal. Xj of n is nothing but presynaptic signals. Simply the change in weight as per the Hebb's hypothesis rule is nothing but the product of the postsynaptic signal Yk of n and presynaptic signal Xj of n. It is multiplied with the learning rate parameter. So that gives the change in weight. This can also be referred as activity product rule. Simply we are doing the product of the presynaptic as well as postsynaptic with learning rate parameter. Another hypothesis. So convariance or covariance hypothesis. So as per this hypothesis, the adjustment applied to the synoptic weight is defined as per Hebs we have seen change in weight, and here as per the covariance hypothesis the change in weight is defined as, here also in a similar way, post synoptic as well as the presynaptic signals product along with the learning rate, but here little different, like delta wkj is equal to neta into yk minus y bar into xj minus x bar. Earlier only we have yk into xj. Now we are having yk minus y bar and xj minus x bar. What is that x bar and y bar means? X bar and y bar are the average values of the x and y, which determines the sign of the synoptic modifications, whether it is in the positive trends or negative trends, minus del or plus del, decides by that average values. So where neta is the learning parameter. Here simply if you take one example, you are having some 10 values in the y signal. Let us take 10 values means average of those 10, and y1, y2, y3, y4 and so on, y10. In that if you are going yk of n means, earlier we have seen, here also you can represent with n also. N is nothing but number of iterations. So where I can read out again, del wkj is equal to neta into yk of n minus y bar into xj of n minus x bar. Here yk of n is nothing but number of iterations. So let us take, you are having some 10 iterations. In the 10 iterations, yk of 1, one value, yk of 2, one value, another value, yk of 3, another value, yk of 4, another value, yk of, and so on, yk of 10, another value. Average of all those iterations or all those values is nothing but y bar. In a similar way, xj of n and corresponding x bar. Among all these, let us take, if you are choosing that yk as some fifth value or some seventh value, yk of 7 minus y bar, average will be fixed, right? But here the corresponding kth neuron output may be yk of 7 or yk of 5 or yk of 3. Which iteration? Okay. So based on that, it may be, based on that average value, your del may be increase or decrease. Whether you need to increase the del value correspondingly to get the desired output, or whether you need to decrease. Let us take, if you want to increase, then you should choose the yk of n more than the y bar. Xj of n should be more than the x bar, then only that positive del wkj will come. Here y bar and x bar are same means your selection should be completely depends on the yk of n and xj of n, whether need to increase the del or decrease the del. So next time if you want to decrease the del, you can choose the yk of, instead of yk of 5, you can go for yk of 2 or yk of 8 also, may be less than the y bar. Likewise you can choose. In particular, it allows a convergence to a non-trivial state. At non-trivial state, it means it should be xj should be equal to x bar and yk should be equal to y bar. This is the ideal case and where it will converge, right? So in this case, this is called a non-trivial state, and here it will converge means So in this case, there is no change in the weights. Xj is equal to x bar and yk is equal to y bar means in the earlier equation yk minus y bar xj minus x bar both will be 0, so that change in weight del wkj is also equal to 0. That's why it will converge. A prediction of both potentiation, that means increase in synoptic strength, and synoptic depression, that means decrease in synoptic strength. So it will predict, we can predict the either enhancement or decrease or depression. A simple graph of hypothesis is as follows. So here, based on that earlier equation, Hebb's hypothesis we have seen. In the Hebb's hypothesis, simply change in weight is nothing but product of the learning rate parameter neta and pre and post synoptic signals. That is nothing but yk and xj. Del wkj is equal to neta into yk xj. That is nothing but, as per the Hebb's hypothesis, that is a change in weight. As per the covariance hypothesis, the change in weight is little different. Instead of directly taking xj and yk, xj minus x bar and yk minus y bar will take. So if you draw the graph, or if you see the graph of that hypothesis, here the graph is between that del wkj on yk. That means del wkj on y-axis and yk is on x-axis. If you see the Hebb's hypothesis, what is the equation? I'll read out just to remember, or you can go to the previous slides. Simply that del wkj is equal to neta into xj yk, right? That is the Hebb's, as per Hebb's hypothesis, that is a change in weight. So now we need to draw the line, or we need to draw the graph between the del wkj and yk means simply del wkj is equal to neta into xj yk means the corresponding slope of that particular Hebb's hypothesis line is nothing but neta into xj, because it is in the form of y is equal to mx, where y is equal to del wkj is equal to m into x is nothing but here yk, the remaining product is nothing but neta into xj. So that's what the slope of that particular line. Next, as per the covariance hypothesis, so it has some the earlier Hebb's hypothesis, it is crossing from the 0 line, because y is equal to mx only. Mx plus c means here c is equal to 0. That's why it is touching that origin line. But here, as per that covariance hypothesis, this hypothesis from the starting onwards, I'm repeatedly telling that hypothesis. What is hypothesis means? Just our hypothesis. I think in the mathematics also you will get that hypothesis. What is our hypothesis? To choose the correct value. So we need to predict something. So that's what the hypothesis. Even hypothesis like variance hypothesis, covariance or variance hypothesis also there. So it is a big topic in the mathematics actually, but in a simple way. Here, just for change in weight only, we have taken that equation, but it has number of iterations. So if you want to, generally in the convergence theorem, we'll use this hypothesis problems. So at what time it will converge, like we have seen in the last slide. So when that covariance hypothesis will converge means when xj is equal to x bar and yj is equal to y bar, right? Yk is equal to y bar, because when both are equal means change in weight is equal to 0. Change in weight is equal to 0 means that it means converged. So we need to bring that condition. It may not be ideal. In ideal case it will be 0, but at least we need to reduce that error value, right? So here, as per this covariance hypothesis equation, what is that equation? Del wkj is equal to, if you see that equation, del wkj is equal to neta into here, del wkj is equal to neta into yk minus y bar into xj minus x bar. In this equation, what is the y-axis? Del wkj is the y-axis. What is x-axis? Yk is the x-axis. So here on y-axis, if you want to have some point, means what you have to keep it here? 0. Yk should be 0. On the y-axis, yk value should be 0, because y-axis is del wkj in that graph. So simply you keep the yk is equal to 0, then you'll get del wkj is equal to neta into 0 minus y bar into xj minus x bar. So that is equal to del wkj is equal to minus neta into y bar into xj minus x bar by substituting that yk is equal to 0. So that's got the point on the negative y-axis, minus neta into y bar by substituting that yk is equal to 0, because on the y-axis your yk will be 0 because your x-axis belongs to the yk. That's why that point minus neta into y bar into xj minus x bar. Next, on the x-axis where it will touch, by keeping that x-axis, on the x-axis your y value should be 0, right? What is y value? Del wkj is equal to 0. By substituting that del wkj is equal to 0 in this equation, if we substitute that del wkj is equal to 0, simply 0 is equal to neta into yk minus y bar into xj minus x bar. But you need to get the yk value. So obviously neta and xj minus x bar are not required. Only yk minus y bar equal to 0, because you are required to find out that yk value, because yk is nothing but x-axis value. That's why yk is equal to y bar is the point on the x-axis by substituting that del wkj is equal to 0. That's why that point is nothing but y bar. The corresponding slope of this line is nothing but del wkj over yk, right? So here the corresponding slope will become neta into xj minus x bar. So if we see the simple comparisons, so it completely dependence of del wkj and yk is linear in the Hibs hypothesis, simple linear line, and both lines you are getting it as linear. The intercept of yk in Hibs hypothesis at origin, whereas the covariance is at yk is equal to y bar. The intercept of Hibs hypothesis line is at origin, whereas the intercept of covariance hypothesis of at x-axis is y bar. Yk is equal to y bar. What are the observation from these equations means? So if you take the first column as characteristics of the synoptic weight, whether it is enhanced or depressed, whether it is increased or decreased. Enhanced means increased, depressed means decreased. So second column is pre-synoptic signal, third column is post-synoptic signal. So if you take if xj is greater than x bar and yj is greater than y bar, in this equation del wkj is equal to neta into yk minus y bar into xj minus x bar. If yk is greater than y bar and xj is greater than x bar, the change in weight is plus, so it will increase, right? So that's what, if any one of the relation of yk y bar and xj x bar is going in an opposite way, that means yk is less than y bar and xj is greater than x bar. One is positive, one is negative, right? Then your change in weight will be negative. So that's what the observation from that equations. So when that weight will increase means when the presynaptic and postsynaptic signals are having xj is greater than x bar and yj is greater than y bar. In other two cases, it has some opposite trends. That's why it will decrease. Xj is greater than x bar means next case yj is less than y bar. So one is negative. Change in weight is negative. So that's what the observation from the equations. In a similar way, xj is less than x bar means here it is negative. Yj, even though yj is greater than y bar, your change in weight will be depressed or it will decrease. Okay, thank you.